Hello everyone. Today let us go through the topic called thermodynamics processes. In this one, today let us consider the first process, isothermal process. So, iso means what? You might have heard the word iso in different disciplines, such as for instance in mathematics, isosceles triangle. See, iso means what? It means something same. So in the case of isosceles triangles, sides are same. So in this term isothermal, something is same. So what is that something? That something is thermal, that is termed as temperature. So this is a constant temperature process. That means temperature is constant throughout the process. So let us consider the ideal gas equation PV is equal to nRT. If we draw a graph for the isothermal process, then the graph obtained will be a decreasing curve. The graph will be basically having pressure on y-axis and volume on x-axis. This decreasing curve is obtained because the pressure is inversely proportional to volume as seen in the equation. So the next thing is isothermal expansion of an ideal gas. In this, work done during isothermal expansion of a gas has to be determined, because work is the only term by which we can get to know whether the gas is expanding or not. So if we consider a ideal gas equation wherein initial stage will be having P1 V1 value and final stage will be having P2 V2 value, then at any intermediate state P comma V will be as shown in the screen, that is P will be constant and V will be equal to V1 plus delta V. So if we want to derive or got to know what is the work done, we can write the equation delta V is equal to P into delta V, wherein by integrating this delta W for throughout the process, that is from V1 to V2, we will get to know that work done will be P constant integration of V1 to V2 dV. So from the ideal gas equation we can write P as RT by V. So work done is equal to RT by V integration of dV. So by following basic mathematical operations, we can get to the final equation of the work done, that is W is equal to RT ln V2 by V1. So by this there is no change in the internal energy of an ideal gas, because here T is constant. T is constant means what? There is change in temperature is 0. So change in temperature is 0 means what? Change in internal energy will be 0. So when the temperature is constant and gas expands, but there will not be any change in internal energy. Considering the first law of thermodynamics, we can write it as delta Q is equal to delta U plus delta W. So considering that the temperature being constant and because of this there will not be any change in the internal energy, so heat supplied will be equal to work done. See, isothermal expansion can also can happen, and even contraction will also happen. In the case of expansion, what will happen? The work done will done by the gas. Work done will be done by gas, and in the case of contraction, work is done on the gas. So considering the first case wherein V2 is greater than V1 for isothermal expansion, that is volume is changed from V1 to V2. So if we put this value, that is V2 and V1 value, what will we see? We will see a positive value. So work done will be greater than 0. So the work will be positive, hence heat is absorbed by the gas during the isothermal expansion. Now in the case, that is second case, what will happen? V2 will be less than V1, that is for the isothermal compression. See, if we put the value of the changed value of V2 and V1, wherein V2 is having lesser value than V1, then the obtained value, that is the overall value of W, will become less than 0. So in this case, what will happen? The work is done on the gas and heat is released. Thank you for going through this video. I suggest you to go through this video twice or thrice to get to know the topic discussed in detail. If any doubts, please bring the doubts in the class. Thank you.